we're back. Hope you had a good break. We're jumping right in. John's here and ready. Welcome to our session on knowledge system application in a marine service organization. And yes, he has said he will take questions at the end, but continue to write in comments and questions throughout. He has a couple polling questions too, so just look to your right for that. So now let's welcome John Yanconi, Chief Engineer at Fincantieri Marine Systems North America, to the stage. Welcome, John.
All right, thank you, Amy. Yes, so again, my name is John Yanconi. I'm going to walk through this presentation. There we go. Yeah. All right, so yeah, I'm with Fincantieri Marine Systems in Chesapeake, Virginia, and I'm here to talk about our knowledge system application that we're developed for our marine service organization. The topics I've got in this presentation are an overview of the project. We'll talk about our design approach, some of the challenges we went through trying to develop this application, highlight some of our results, and then talk about where we're going next. Okay, before I get started though into the project overview, I want to get a little sense of who the virtual audience is here. So if you can, respond to the questions in the poll there. You should see that on your screen. Tell me a little bit about your business type. Is it a manufacturing or production type organization, a service organization like ours, retail business, or some other type of business? If you can, go ahead and reply. I'll take a look and see who the makeup of our audience is. Looks like most people are as expected in a manufacturing and production organization. I understand that. Okay. So about over 80% in manufacturing and production. Okay, let me go on then and talk about our service organization and explain something. Okay, there we go. All right, Fincantieri Marine Systems North America. Fincantieri, our organization is a business group in the U.S. that rolls up to Fincantieri Group, which, if you may have heard of Fincantieri, they're best known as a large global shipbuilder that's headquartered in Italy. They have shipyards all over the world and are known for building premium high-end ships, particularly if you've ever been on a cruise ship, that type of premium high-end detail, similarly in naval vessel applications. So premium ships built all over the globe, and our little business unit focuses on selling and service marine components and systems, particularly power systems. So like the type shown here, large generator sets or propulsion engines, propulsion systems used in a variety of particularly military applications in the U.S. And our main customers are the United States Navy and the U.S. Coast Guard. And so our equipment's on board ships like this Navy ship shown in this picture here, and we provide service for those types of vessels all over the globe. Okay. So for the project overview, this project really evolved as part of an R&D project that was awarded from a consortium, the National Shipbuilding Research Program, that's really funded by the U.S. Navy. And their objective is to advance technology through these consortium R&D type programs. And they want to accomplish that in this case through seeding technology through application of either artificial intelligence or knowledge systems, which are fairly popular or growing in some industries, but slow to be deployed in the marine industry. So that's what this program stems from. And what interested us about it, Fincantieri Marine Systems, was we saw it as a way to improve efficiency in our operation by using a knowledge system and databasing information that helps us perform not only more efficiently, but avoid costly mistakes. So that's what we saw as the carrot for us. But when we started, we really didn't have an idea of what that involved. And part of the project involved partnering with RS Knowledge Systems and In so doing, we got the help of Steve Boisford, who's our application engineer working at Oros. And he brought in this analogy, which many of you may have seen before, but it was helpful for us to get started because we had no idea what a knowledge system really was going to do for us. And the analogy they use is often the large map, atlas map versus the Navigator. And that helped us understand by simplifying the knowledge and provisioning it as we needed it rather than getting it all at once and hard to find. We saw that maybe there was a case for us here to apply to our operation. So we took that analogy and applied it to our use case in a similar sort of way. We know we had a document central organization, and our information was often repeated, hard to find, spread all over our shared drive network like a lot of organizations do. And we thought, well, if we could organize that knowledge, put it into one system, help it integrate through the workflow of our operation, put more graphical interface instead of a lot of words, have it so we could easily monitor and monitor progress and compliance. That type of database and workflow structure could be useful for us. And that's how we approached it. So once we understood that, we said, okay, we got a project. How are we going to do the design approach for it? So first we set off and, as any good projects, mapped out our goals. And we thought about how we could use the knowledge system and where we could gain efficiency. And first it was to reduce cost of sales, which we found many examples of what we thought we could do with the system to do that. We wanted to make sure we were tracking our deliverables and didn't miss any and achieved them all on time. And we wanted to make sure as we looked across the system, we could improve on our estimates on the front end of the business and get a more credible estimate for those. Similarly, if we're databasing and tracking information, we could use the information we gathered to automate skill level certifications for our technicians. We thought that would be a great use. And as well, track the product capabilities and how they're doing in the field, gather that data and measure that. And if we made data more available, we figured our employees would be more satisfied as well as our customers. And then the big one that we were facing was we were going through NIST compliance at the same time. So whatever we did with our information had to remain secure. So those were our front end goals. As we mapped out the program, we figured, okay, how are we going to apply this system? We looked across the whole operation from start to finish, all the way from a customer inquiry to closing out a job, and decided we could apply it across that entire operation. But for the purpose of this development project, we figured we would first focus in on the back end half of the business, which is executing a service job, from planning that job to executing that job and then closing it out. And that would involve primarily our service department, service coordinators, the mechanics doing the work, and program management. So that's how we pieced out the program in terms of development. Our next step in the design process was to go ahead and map all workflows. So we did flow charting here. This is an example of what that back end process within that service department organization. And we did this to identify not only the workflows, but where the data was and where the knowledge was that had to be provisioned and made available to the users at the appropriate time. We did that through the entire operation from start to finish, but this is just an example from the service department, the back end piece. Then we had to set the scope. And originally, of course, we thought we would want to bite off a big apple and say, we'll do the whole engine overhaul. But then we backed up from that, realizing that was a lot of knowledge and too much to provision in this development effort. So we scoped it back to a 1,000-hour maintenance event. And so that involved basically 10 procedures, 10 service procedures that we would provision. And that was something more reasonable, like changing filters, adjusting valve clearances, enough to test out the process, but not too much to overwhelm us trying to develop this. That was the approach. So then we went through and started implementing that and ran into some challenges. And these are I highlight these since most of you are in a production environment. I highlight the differences for how this compares to our service organization. I have years of experience in the production type of organization as well, so I understand how this system would work more easily there. So, but in a service organization, first we have a work environment that makes it difficult to develop in. We're on board ships. About 90% of our work is on board ships. It's not much in-house. So getting to those locations is difficult, and they're not the most friendly places to be on when you're on board the vessel. So working in that environment, it's not the most PC friendly place. It's not an office space. And it's offline. So that's challenges for implementing the system. There's no internet connection in the engine room. The other thing is we're always directly interacting with our customers, and they're imposing requirements on us. And it's not maybe the best place to be trying new things out. They don't have any patience for that sort of thing. They expect you to perform and get off their ship. There's a lot of emergent work, so we could go in there with a plan, and we need to react quickly because as any service and repair, if you've done anything like that at home, it never works out like it's supposed to. So it gets emerging work, and we have to react to that. The customers own our equipment, so it's not easily accessible to us all the time. All of our subject matter experts are, they're out making money, they're working, so it's hard to get access to them when they're deployed. And the results are always hard to measure. If you don't get them the first time, they go with the ship, and it's a long time before you might see that ship again. And of course, we've got that NIST compliance thing that we have to deal with on security controls. The bottom line for a service organization, developing a software application like this knowledge system is a really difficult task. Now, what we did to kind of mitigate some of that, first, we had top-level commitment. Our CEO was a champion of this program from the start, and that really helped to get everybody committed to try to implement this. So it was taken seriously. The other thing is we put a dedicated, experienced subject matter expert to lead the project. I have over 35 years experience. I didn't have to figure out how to service an engine in order to go lead this project. That really helps. You don't want to learn the operation as you're trying to develop the system. And we did set out with well-defined goals and workflows and data maps like I walked through in the design approach. The other thing is we have a small team, so we had to limit the participation to a core group, and then just extended project team that's partly involved so we can execute more lean. And then we narrowed that scope and came up with a practical use case. We had very little program management. We had a high-level plan, and we knew what we wanted to accomplish, but we didn't overdo it. And we used virtual demonstrations to share the design concepts out with the extended team members and get their feedback. We did a pilot test. Since we couldn't get out on the vessels to work on this, we had to simulate that with an engine in a shop. Bottom line is we had to show value everywhere we went. So there's a big administrative burden for any software application, and we had to make sure we had an offset to that. Results. So we provisioned our knowledge. We had to choose how we were going to do that, and we decided to use what's called a method type procedure. All of our procedures we put into this standard format that we developed. For any service repair operation, we'll always go through a disassembly, clean inspect, repair assembly, validate and test type of process. So we built that into this template and used methods, graphical method representation to provision that knowledge. And each one of these steps then could be broken down into sub-steps, but we tried to make it simple so a mechanic could easily follow this type of routine and get access to the knowledge they needed at the right point in time. So that's the template we developed. And then we took those procedures as we developed each one and bundled them together into this work package process for simulating this 1,000-hour maintenance event. and we ran a pilot test with it at our shop in Florida, where the mechanics are based out of, and essentially went through each one of these things and simulated the job. So we involved a service coordinator who had never been in the system before, hadn't been trained on it, and myself, and we had Steve Boisford from Auris down with us to give him a quick over-the-shoulder tutorial on what to do. But we had him log in and say, okay, go ahead and create your job. Here's where you go get your provision procedures, and then assign them to it, task them out into a real job, just like you would do in an analog system with paper. And he went and did that and assigned him to a mechanic. Then we took a mechanic who hadn't been in the system before either, and so he had him log in and showed him how to go in and access his jobs, his tasks, and he pulled them up and opened them up and walked through the process. Now, admittedly, it's not like they were untrained mechanics. These are mechanics who know how to do these jobs or these tasks, but they had never done it in this sort of way before in this guided approach. And so that's what we were testing out on the system. So basically, the mechanic pulled up an example of one of these provisioned tasks. In this case, this procedure shows an example of how to change filters, fuel filters, and he would walk through and drill down through each one of them and check off each box. Some of the more complicated ones, like this valve lash procedure, which, by the way, won the KPAC of the conference, KPAC award, so the best KPAC. This one is fairly sophisticated because it has 10 sub-procedures, one for each cylinder, and then it allows you to drill down and enter data and store that data and check compliance to the specifications. So that's a great feature for our quality assurance control. And then we asked him to, if he found something, to raise an issue and walk through that process, and could easily take a picture of an issue. And these are things that commonly happen, and he was able to do that very quickly. And then as the service coordinator sat in his office, he could sit out there and monitor what was going on the shop floor with the mechanic completing each one of these tasks. So there's a program management element to that to monitor each of the tasks and know whether he's got compliance or issues being assigned to him. The pilot test was great. We got some fairly good feedback there, and we felt like the effort we made was worthwhile. Basically, our next steps going forward, the actual program, the NSRP program, ends at the end of October. That's its final event there in the end of October. Our work will continue on, though. Coming up, we've got we want to apply this outside of the workshop on board another ship. So we're going to take a work package out to a ship and try to execute it in real world. We've already migrated the system over to the GovCloud for NIST compliance. That'll keep the system secure. And then we're going to generate some more reports and some non-standard reports. We've got to migrate data from our accounting system, job-related data, which enables, the RS system does interact well with other systems, and so we're going to show that data transfer capability. And then the big feature we have is this offline capability that's being developed at RS. That's going to allow our mechanics to go out in the field, replicate their system, complete their work, and then synchronize the results when they can get out of the engine room. That's our next steps. Summary overall. One, the knowledge system development is really a challenging thing to implement in a customer-facing service organization, but it can be done. And so far, I would say using a system like RSKS really provides, since it's off the shelf and proven and very customizable, that was something that I think we've shown we can model in a service organization. And so we feel pretty good about that. Our results were practical and gave us a pretty good idea that we could gain some efficiency here and certainly improve our quality control. And so I think we could get what we want, accomplish our goals if we get that offline capability and the synchronization that we're looking for. And that's basically it. So before I end, I'm going to ask another polling question. Based on the experience I described here, how valuable would this knowledge system application be in your business, having seen what we've done with it? One, not much, somewhat, or a critical type of application. If you can, go ahead and respond to the polling questions. And in the meantime, I have Q&A. If you have questions, you can type them in the chat, and I'll try to respond to them. And then you can also add, provide whatever feedback is using that link.
Perfect. And do you have the results? Do you see them there of that last poll question?
Let me see. It's still coming in.
Yeah, it takes a little
And
bit.
we've got, well, the good news is nobody selected not much. And it's, I see about a third in somewhat and 2/3 in critical.
Okay, very good, very good.
All right, I think I'm going to set up a consulting business on it.
Yeah. And yes, as you mentioned, you did win the KPAC competition. So that was cool to see some of the inside look into that. Yeah, you're multi-talented. So Nick is saying that he's looking forward to seeing how Oros supports the project being able to use offline and then resync to the live database once available. This will really open up some use cases of the live application and mobile device platform.
Yes, and I could say I've had prior experience, similar situation at another organization where we did do exactly that remote capability. And that in a lot of, we're not the only place that has offline issues, and that's a real key feature.
Mm-hmm. Jeff is asking, did you have any concerns that mechanics would want to use computers?
Yes. So we still, and the question of what device they're going to use is still an open question. I didn't explain it in our pilot test, but we actually had a laptop, a tablet, and a cell phone available. And the go-to device that the mechanics already have in hands are their cell phones. So that's what they want, but it's too much information generally on a cell phone screen. So we knew that was going to be a challenge. There's really not, laptops are a little bit, I'll say, difficult to manage in an engine room. And so we expect tablets would be the primary one, but they clearly prefer the phones and migrated right away to that. So I think what'll happen is they're going to use them all of them. I think that's what'll happen. They'll use the ones that they want to use.
Yeah, so I think you just covered Susan's question in that the offline application can be a mobile app.
That's right. That's
yeah.
right.
Yeah, exactly. Okay. Aaron says, great presentation. Really enjoyed being able to see the complete picture from what the mechanics were working on to the Oros result tracking.
Yeah.
Thank you, Aaron. And then Nick, well, I guess he's actually asking Jeff, is more mobile friendly access coming soon? So that's a question directed towards Jeff. Okay. Checking for any other. I have a question for you. What about the knowledge system application do your users like the most? And on the flip side, if you wanted to say, you know, what they don't like, it's up to you.
Right,
Yeah.
right. So they do like the graphical interface and the ability to pull up information easily. So it's you know, the analogy they deal with right now, they get a binder of so much information that they ignore it. So this is little chunks of information, and that piece they like. And they like the pictures and the ability to snap a photo and upload it in a simple step. So that part they like. What they don't like is having to go through and be access it check by check. You know, in some ways they see that as extra work. However, these are things they're supposed to be doing now already. So it's a bit of a you know, we got to make sure we're not burdening them with work that they don't need. So that's what they're really resistant to, is if they see it as more work that's unnecessary, no value, they don't want that.
That makes sense. And I've got just one more question here. What determines if the business succeeds in, or the system? Sorry, not that's, I think I misspoke. What will determine if the system succeeds in your business?
Right. So if it's not implemented well and not used, it's just like anything else. It won't be successful. For it to succeed, we definitely need the remote capability. The work is remote, and if we don't have that easy synchronization, so the data flows from the engine room in the ship back to the home site, then yeah, we're kind of dead in the water.
Yeah. Well, and thank you for putting up the barcode. You have the option of scanning that or clicking the link that I've put into the chat to take the quick survey on this session. We always appreciate your feedback. And of course, you can reach out to John directly if you come up with any further questions.
Amy, I do have one clarification.
Yes.
Susan's question, which
Okay.
in terms of offline application, so the offline piece, part of that could be in an application, but I think our intended use will still be a browser-based execution of that software. We could do a mobile app version, and it may be a combination of the two, to be honest. But I think to get our full capability, we'll probably be running the browser-based application, but then synchronized remotely.
Oh, perfect. I'm glad you clarified that. And speaking of Susan, the next presentation she will be delivering at 12:35 p.m. Eastern, Susan Bachman on partner portal and partner sharing applications at General Motors. So we really appreciate John and you all joining us for this session.
All right.
All right. Yeah, thank you so much.